Good evening, my dear children. Welcome to Vishnupriya's chemistry vlog. Today, I am going to teach you last part of science chapter 1, standard 9. In my previous video, we have discussed about the different state of matter, that is solid, liquid and gas, and their properties, physical property and chemical property. Now we learn about the effects of change of temperature and the evaporation, the last part of the topic. So without delay, let us start. Okay. First one is effects of change of temperature. Okay. So we know that on last video I have told you that on increasing the temperature of a solid, the kinetic energy of the particle increases. Due to this, particles start vibrating with greater speed. Okay. And this energy overcomes attraction force between the particles, and particles leave their fixed position and start moving more freely. Okay, a stage is reached where the solid is converted into liquid, and the minimum temperature at which a solid melts and becomes liquid at atmospheric pressure is called melting point. So understand what is melting point? Now the temperature at which a solid melts and becomes liquid on the basis of atmospheric pressure is called its melting point. Then come to the process of melting. The process of melting that changes of solid state into liquid state is called fusion. So what do you mean by fusion? And the fusion is the melting, the process of melting, that is change of solid state into a liquid state is called fusion. And the heat gets used up in changing the state by overcoming the attraction force between the particle. Okay, and that amount of heat energy that is required to change 1 kg of solid into a liquid at atmospheric pressure at its melting point is known as latent heat of fusion. Okay, so you remember what is latent heat of fusion. Now that means the amount of heat energy that is required to change 1 kg of solid into liquid at atmospheric pressure, and its melting point is known as latent heat. Okay, then let's come to the next slide. When you supply heat energy to water, particles start moving even faster, and at a certain temperature a point is reached. Understand, my dear children? If you do not understand, if you have any query, then you can put your query in my comment box. I will clarify. Okay? When the particle have energy to break free the attraction force of each other. At this temperature, the liquid starts changing into gas. And this temperature, which is liquid starts boiling, is known as boiling point. At the temperature where the water starts boiling is known as boiling point. It is the Buck phenomenon. We will further discuss it on higher class. Particles from boiled liquid gain energy to change into the vapor state. For water, this temperature is 373 degrees Kelvin. Okay, Kelvin, what is Kelvin? Now, Kelvin is the SI unit of a temperature. 0 degrees Celsius is the 273.15 Kelvin. For a convenient, we take 0 degrees Celsius is 273 degree Kelvin. And after rounding up the decimal point, we have changed the temperature Kelvin scale to Celsius scale. So in Celsius scale, we have to subtract 273 degree from given temperature, and you have to convert the temperature Celsius scale to Kelvin scale. We have to add 270 degree at the given temperature. So for this, boiling point of water is 100 degrees Celsius, or that means so we have to add 273 degree. Okay, so for water the temperature is 373 degree Kelvin. Okay. Then come to the water. Vapors at 373 degree Kelvin and have the more energy than water at the same temperature due to particle and steam absorbing extra energy in the form of latent heat of vaporization. Then solid state, because if we put heat, then it becomes liquid state, and again heat, it becomes gaseous state. But gaseous state cool, it becomes liquid state, and it cools, it again comes into solid state. Okay. Okay, you understand the conversation? Okay, we can infer that matter change into another state by changing its temperature. Understand, my dear children? We also have some change that directly change solid state into gaseous state and vice versa without changing its liquid state. So changes of solid to gas is called sublimation. You have to understand and remember it. What is sublimation? Means change of solid to gas is sublimation. Change of gas to solid is deposition. All occurs without changing into liquid. Then come to next slide. Okay, that means effect of change of pressure. Okay, the difference in various state of matter is due to the difference in the distance between the constituent particle. Applying pressure and reducing temperature can liquefy gases. So pressure and temperature determines the state of substance, whether it will be solid or liquid or gas. For example, solid carbon dioxide is stored under high pressure. Okay, solid carbon dioxide get converted directly to gaseous state on decrease of pressure of atmosphere without coming into liquid state. This is why solid carbon dioxide is known as dry ice. So remember the question, why solid carbon dioxide is called as dry ice. Okay, in this here figure 1.9 in interconversation of the three state of the matter. Solid becomes liquid and becomes gas, and the gas becomes liquid and becomes solid. Okay, so you have to understand what is the figure 1.9. If you have any doubt, you can put your query on my comment box. Okay, if solid gets sublimation into gas, then it condenses a liquid, then solidification it becomes liquid. Okay, but solid fusion liquid and vaporization gas, and again deposition into solid. Okay, then come to next slide, which is evaporation. Now it is a phenomena of change of liquid into vapors at any temperature below its boiling point is known as evaporation. So what is evaporation? Now change of a liquid into vapor at any temperature below its boiling point is known as evaporation. Here this figure resembles evaporation, liquid into the vapors at any temperature. Okay, liquids become vapor is called evaporation. Okay, then come to our next slide, factors affecting evaporation. Now increase with the increase of surface area. That means if surface area increases, the rate of evaporation also increases. And the increase with increase in temperature. If the temperature increases, then the evaporation also increases. With the increase in temperature, more number of particles get enough kinetic energy to go into the vapor state. So you have to remember all this. And it increases with a decrease in humidity. If humidity decreases, the evaporation increases. What is humidity? And the humidity is the amount of water vapor present in air. If the amount of water in air already high, then the rate of evaporation also decreases. Then what is the another factor? Increase in wind speed. If the wind speed of the particle of water vapor moves away with the wind and decreasing the amount of water vapors in surrounding. So what are the factors? Now, surface area, temperature, humidity, wind speed. Wind speed are the factors affecting evaporation. Okay, you have to understand, you have to remember the above factors. Okay, then come to how does evaporation cause cooling. The liquid keeps on evaporating. The particles of liquid absorb energy from the surrounding to regain the energy lost during evaporation. Understand what does it mean? The particles of liquid absorb energy from the surrounding to regain the energy lost during the evaporation. This absorption of energy from the surrounding makes the surrounding cool. Okay. So this is the last part of chapter 1 standard 9 science. So if you have any doubt, you can put your query on my comment box and I will clarify. Children, if you like my video, please like, share and subscribe. Thank you. Bye bye.